Hello, welcome. I'm Sandhya. In this part of the course, Programming for Problem Solving video lectures, today we're going to look at a topic called as nested functions. So before we go ahead, let us let's try to answer the first question. What is a function? A function is a block of code that does a specific work. Now, second question, can we nest functions? The answer is obviously yes, because we have already seen printf percentile d printf hello. It'll print 5 hello. We know that, right? Hello 5. So now the point is, yes, nested functions is a concept of writing, using one function inside another. That means, again comes two topics. Functions has essentially two things: function definition and function call. Should I call, is it calling one function inside another, or is it defining one function inside another? Defining one function inside another does not make much sense, because functions itself means independent blocks of code that does a specific work. So that's why nested functions means the process of calling one function inside another function. So example, main is calling function 1. When you go to function 1, there's function 2. Inside function 2, there's nothing. So after executing function 2, control just returns here, finishes the next part of the function 1, goes back here, finishes the next part of the function, this part under main function, and then close of main, so therefore comes out of the program. So this concept is called as nested functions. The process of calling one function inside another function is known as nested functions. Example of nested function, here I have a pretty simple nested function program. We all know that basically calling function is main. So here inside main, a is 10, b is 5. So I have a variable called average. So I'm calling a function average of a comma b. So whenever average is called, what happens in a multi-function program? Whenever a function is called, what happens? Control jumps from here. The control jumps to the place where the function is defined. Now the control jumps here with the values a and b. A is 10, b is 5. So therefore x value is 10 and y value is 5. So now we again got a call for another function called as sum of x comma y. So what happens, because it is sum of x comma y, what happens? Because inside one function you have a call to another function, the control jumps to the place where the function is made, x comma y. What is x value? We know that x gets a copied value 10 and y gets a copied value 5. So what is the job of the sum function? Inside the sum function, there's one statement, return x plus 5. What is 10 plus 5? 10 plus 5 is 15. So you are returning to where, which place do we return? We don't return to main. Any function returns its value to its calling function. What here, sum is a call function to the calling function average. So therefore, 15 is returned to this place. So now we have s is equal to 15. After that, what do you have? Return of float of yes by 2. Float of yes makes it 15.0 by 2. What is 15.0 by 2? Obviously, it is 7.500. Because you are returning a float value, the return type of the function is float. So therefore, when I print average value, the value will be 7.500000. So that's about how do we use this concept called as nested functions. Okay, here main calls average. So main is a calling function, average is a call function. But here average in turn calls sum. So here again average becomes a calling function to a call function called sum. So therefore anything can be a calling function or a call function. Okay, before we go for it, now do we talk about, is there anything else that needs to be talked much when we talk about nested functions? Yes. There is a lot more when we talk about nested functions, because we got to now discuss about a special class of nested functions, and that's called as recursion. In C language, recursion is a special class of nested function. How do people define recursion? So in this part of the video, we'll also look at what is recursion, how is it executed, what is the base case, what are its merits and demerits, and what is a stack frame, and a few examples for recursion. Okay, so what is recursion? Recursion is a process of repeating the items itself. So in general, C program supports recursion, which is a special class of nesting functions. So a function calling itself repeatedly is called as recursion. What happens during recursion? During recursion, a function is itself calling repeatedly until some condition is met. Okay, that condition is called as base case. A function calling itself repeatedly until a base case is met is called as recursion. Base case is a stopping condition. Upon meeting the base case, the recursion terminates. Okay, so now what is stack frame? Stack is basically a data structure, a memory data structure, which is used to support recursion, and stack frame is the list of values that are pushed to the stack whenever a recursion is executed. So therefore, recursion is a process by which function calls itself repeatedly until some specified condition has been satisfied. When a function calls itself, a new set of local variables and parameters are allowed into the stack, and the function code is executed from top with these new variables. And these variables are called a stack frame. The values that are pushed into the stack to allow recursion to happen is called a stack frame. A recursive call does not make a new copy of the function, only the values are being updated each time. So stack above stack are created to update the values each time. So whenever a recursion returns, the old local variables and parameters are removed from the stack, and the execution resumes immediately with the next recursive stack. The main advantage of recursion is it is used to create cleaner and simpler codes. Let us see an example for recursion. So this is one of the examples where a function f is calling f, but there is another way also possible. Here f is calling g and g again is calling f. Yes, the first one is called as direct recursion and the second one is called as indirect recursion. There are a few rules for recursion. Recursion is infinite process, so you have to have a base case that terminates the recursion after finite steps. And the second one is every recursive method must make progress towards the base case, not to the infinitive case. Suppose if my base case is n equal to 1, from 5 I got to come down to 1 each time. But that does not mean from 5 I go to 6, 7, 8, 9, 10 whenever I meet the recursive base case. Okay, so that's the second rule. Let's take up a simple example. That's factorial of a given number. What is factorial? We all know that factorial is product of numbers. N factorial is n into n minus 1 into so on up to 1. Or in other words, product of 1 to n numbers is called as n factorial. Okay, so therefore, we can definitely write factorial as 5 factorial is nothing but, if given a chance, how do we write 5 factorial? We write 5 factorial as, so say suppose, okay, let's concentrate on writing 3 factorial. So if someone is asking me to write 3 factorial, we'll write it as 3 into 2 factorial. So we can also write it as 2 into 1 factorial. We can also write it as 1 into 0 factorial. What is 0 factorial? We know that the answer for 0 factorial is 1. 0 factorial is 1. We all know that. So therefore, 0 factorial is 1. So we'll move to understanding 0 factorial, which is 1. So therefore, 1 into 1 is 1. Now, here the answer comes 1. 2 into 1 is 2. So here the answer is 2. 2 into 3 is 6. So here the answer is 6. So finally, the answer for 3 factorial is 6. So therefore, when you check this out, this becomes, f is equal to factor of n. So how do you calculate the factorial? Long int factor of int n. If n is 0 or 1, you will return 1, which is the base case, because 0 factorial or 1 factorial is 1. Else return n into factorial of n minus 1. So now let us see this example. N is 5, so 5 into factorial of 4. Now, what is the condition here? 5 is 0, 5 is 1, false. So you're calling 5 into factorial of 4. But factorial of 4 is again equal to the same function. So 4 is equal to 0 or 4 is equal to 1, false. So you will return 4 into factorial of 3. Again, factorial of 3 is a call. 3 is 0, 3 is 1, false. So you'll go to the else part. 3 into factorial of 3 minus 1, nothing but 2. Again, factorial of 2, 2 is 0, 2 is 1, false. So therefore 2 into factorial of 1. So now you'll move to 1 equal to 0. Yes or no, false, but 1 is equal to 1. Yes, true. Logical OR is true if at least one of the instructions is true. So true, so therefore you will return 1. 1 is returned in the backward case, it becomes 1 into 2 into 3 into 4 into 5, which is nothing but 120. If we ever need to understand it more diagrammatically and more clearly, there's one more representation, that we can check out that will make us, much more understandable. So this is what happens. All these are the values that are pushed to the stack. This is our stack look, it happens with the stack. Fact of 5. Function call processing requires stack, so pushes all the temporary variables into the stack, produces a stack frame, jumps to calculating this. 5 is not equal to 0, so 5 into factor of 4. 4 again calls 4 into 3, like this. And values are returned recursively to its calling function, then finally getting the value 120. So let's take up a few more examples about recursion. So this is an example where you're printing numbers from n to 1. Okay, so if n less than 0, you're returning. Otherwise, you're printing n and just printing n minus 1. So you go back when your n is less than 0, you'll just stop it. N minus 1, n minus 1, it decrements like that. Okay. So now sum of first 10 natural numbers. So this is a recursive function where we are calculating sum of first 10 natural numbers. N plus some recursive of n minus 1. You go on adding. Just like how we did multiplication, here we'll do n plus n minus 1 plus n minus 2 plus so on up to 1. This is nth Fibonacci number, and this is sum of recursive array n elements. These are a few examples. It's just for understanding to make you know that there are a lot of possible ways in which you can, probably try to build up recursion programs. What are the types of recursion? Basically, there are two types of recursion that we have already seen. That is direct recursion, indirect recursion. The function calling itself is direct recursion, and the function calling, a function one calling function two. Function two in turn calling function one is called as indirect recursion. But in addition to this, there are also two types of recursions. One is called as tail recursion and the other is called as non-tail recursion. Tail recursion is a process where a function, a recursive call is the last thing to do inside a program. If the recursion call is the last thing to do inside a function call, then it is called as tail recursion. For example, here return factorial of n minus 1 does nothing, simply just returns the control back. Whereas in this case, after returning the answer of n minus 1, it is waiting to calculate n into something. So therefore, this is an example of non-tail recursion. If you have still some operations pending to do after returning from the recursive call, it's called as non-tail recursion. Whereas if you do not have any operations pending and if the recursive call itself is the last statement inside a program, it's called as tail recursion. Now, after seeing all this kinds of, all this about recursion, it becomes extremely important for us to understand some advantages and disadvantages of recursion. What are the merits of recursion? The advantages include, reduces unnecessarily calling of so many more functions. So recursion, one can solve complex problems in an easy way. That means, if the iterative solution is bigger, sometimes recursion solution may be smaller. Recursion can reduce time complexity and recursion makes tree traversals easy. Especially tree traversals and implementing dynamic data structures is one of the important cases where recursion is heavily used and makes the job easy. Recursion is more like problem, more like formula oriented. Okay. On the other hand, recursion has got its own set of disadvantages because recursion uses stack each time. Recursion is a slower process. Recursion takes more time. Recursion takes more memory. Whenever you don't write a proper base case, recursion may end up in creating stack overflow or memory fulfillment. Okay, so recursion uses more time and difficult to abort, and it is almost very difficult to find out errors inside recursion because you don't know where the error has come from, and it is also difficult to abort it in between. So these are all the merits and demerits of recursion. Recursion is a very important exam question, students. So I request you to kindly go through the lecture once again and prepare yourself. Before we close, try to write a C program that displays numbers from n to 1 using recursion, and write a C program to search for an element in an array using recursion. And also write a C program to find GCD of two numbers using recursion. Okay, so these are the programs that we expect you guys to do. And thank you.